So yesterday we went over measures of center or central tendency. Today I want to go over measures of variation. Okay, and a way to explain this, the book has this nice graphic of two basketball teams. And both Team 1 and Team 2, they have the exact same measures of variation, okay? So the mean is this, the mean is the same at 75 inches. The mode is the same at 76 inches. And the median is the same at 76 inches, okay? So these all have the same measures of center, okay? But if you notice, Team 2, it's much more spread out. We have a player that's 5'7", much shorter, and a player that is 7 feet tall, okay? Whereas all these guys are kind of in the 6-foot range, from 6'1" to 6'6". This varies much greater, from 5'7" to 7 feet. So, in order to describe those types of, or that quality of the data, we're going to use measures of variation, or another word would be measures of spread. Okay, so one that you're probably really familiar with is range. Okay, that one you've been doing since, I don't know, the 5th grade, 6th grade, something like that. The range of the data. And another one that you might not be as familiar with would be standard deviation. Okay, and we're going to go over each one. Okay, so first let's go over the range. Range is just the difference between the largest and the smallest values. Okay, let's put right values there. So let's do Team 1. Okay, so Team 1, the largest player is 78 inches. And we're going to subtract the smallest player's height from it, 72. And that is going to give us 6 inches. Okay, the range is 6 inches for Team 1. However, Team 2, I think we're going to notice, we noticed that the data was more spread out, right? So Team 2 is going to have a larger range here, I believe. And that's going to be, 84 minus 67. And that's going to give us 17 inches, okay? So this is 17, that's 6. I mean, we kind of knew this, but what this does is it tells us that maybe Team 2's data is a little bit more spread out than Team 1's. However, it doesn't take into account any of that middle data, okay? So these could be outliers, something like that. Just be aware that maybe range is the weakest of these measures of variation, just because it only takes into consideration the largest and the smallest. Next, let's talk about standard deviation, and more specifically, sample standard deviation. The calculation for population standard deviation is a little bit different, and we're going to do it in the next video. Today, we're just going to talk about sample standard deviation. Okay, so that takes all of the observations into account. Remember, range only took the largest and the smallest. This takes all of them into account, which means it's a better measurement, but it also means that it's a little bit more of a pain in the neck to calculate. Okay, and it measures how far on average observations are from the mean. Okay, so the first step is going to be calculating the mean of your data. And the larger the variation in data, okay, the more the data is spread out, the larger the standard deviation is going to be. Okay, so that's kind of how you should interpret this. Oh, my pen died. How you should interpret this data here. Okay, sorry about that. So let's calculate something. Let's do it for Team 1. Okay, so Team 1, that's the team that we're going to calculate the standard deviation for, okay? So the first thing we have to do is calculate the sample mean. Okay, so sample mean is the first thing to do, okay? Yeah, so we're going to take 72. Oh, you know what? I'll write that's sample mean is equal to 72 plus 73 plus 76 plus 76 plus 78. And we're going to divide that by 1, 2, 3, 4, 5. 5. Okay? If we do that, 72 plus 73 plus 76 plus 76 plus 78, 375 divided by 5 is equivalent to 75. So sample mean is 75. Oh, you know what? It said in the book before. Oh, whatever. Okay. So we have our sample mean. Now we have to make a chart of deviations from the mean. So the next thing would be deviations from mean chart. Okay. So I got my height here. And then deviation. So deviation is going to be our x value, the height of the individual, minus the mean, okay? So we got 72, 73, 76, 76, and 78. Okay. And our mean is 75. So 72 minus 75 is equal to negative 3. 73 minus 75 is equal to negative 2. 76 minus 75 is equal to 1. Same thing. And our last one is equal to 3. Okay, so these values, if you did your calculation right, these values should, if you add them all up, they're going to equal 0, okay? So that's a little helpful trick to make sure you did your math right. But summing equal to 0 doesn't help us, right? I think we what we want to do is we want to sum these up, okay? So what we're going to do is, in order to not get a 0, we're going to square these values, okay? We're going to square the values, okay? So negative 3, I'll write these in orange. Negative 3 squared is 9. Negative 2 squared is 4. 1 squared is 1. 1 squared is 1. 3 squared is 9, okay? So now we can add all these up. Okay, this squared, actually I should have put another column. This is the squared deviation. And if we sum these up, 24, okay? Okay, so we have our squared deviation here of 24. All right, so the notation for that is this, right? It's just the sum of all of these numbers squared, and that's equal to 24. Okay, so now what we want to do is we want to compute the sample variance, okay? And we're almost done with this. Let me spell variance, right? And all you're doing is you're taking this number 24, this sum of all of these squared deviations, and you're dividing it not by n, okay, not by the sample size, but one less than the sample size. So the equation is going to be this, right? I mean, it looks a little weird with the summation notation there. Okay. And that's going to be Sample variance is S squared, okay? You'll see why it's S in a second. Okay? In this case, this is 24 over n minus 1. So what was our n? 1, 2, 3, 4, 5. 5 minus 1. So this is 24 minus 4, which is 6. All right. So this is considered our sample variance, okay? So the sample variance is 6 inches squared, okay? That doesn't make a whole lot of sense for right now, but what we're going to do is we're going to get the standard deviation, okay, we're going to take the square root of it. So standard deviation, S, is, the square root. So in orange, it's standard deviation. I'll write that in a second. Okay, so in our case, it is the square root of 6, which is approximately 2.45. Okay? Oh, shoot, no. It's 2.449. Oh, yeah, 2.45. Good. Okay, 2.45 inches. Okay, that is the standard deviation. So the question is, what does this mean? Okay, so what it means is that on average, the heights of the players on Team 1 vary from the mean height of 75 inches by 2.4 inches. Okay? So if you happen to calculate Team 2's standard deviation using the same method, sample standard deviation, you would find out that their standard deviation is 6.2 inches. Okay? So that's saying that, on average, the heights of players on Team 2 vary from the mean height of 75 inches by 6.2. So what we saw, a while ago was that Team 2 is more spread out, right? And that is what this is saying to us. If we compare these two standard deviations of Team 1 and Team 2, we see that the standard deviation on Team 2 is much greater than the standard deviation on Team 1, meaning their data is more spread out.